Now, how are you going to start your numbering? Like I said, the longest continuous chain, first of all, we have to know the longest continuous chain. Now, the longest continuous chain is that chain that is longest and it is continuous. Of course, just looking at it, you agree with me that this from here like this, the chain that ran from here, is there a way? Okay, yes, I can actually use this. The chain that ran from here, through here, like this, like this, like this, like this, like this, to here, is our longest continuous chain in this case. Are you getting this? The chain that is longest and continuous. Do you understand? So, longest continuous chain, you can actually take a branch. This is not a substituent. This is not a what? A substituent. It's part of the chain. Are you getting it? So, the longest continuous chain is the one that runs this way like this. Now, the next question is, where are you going to number from? If this, like this, is our longest continuous chain, it means this group here is a substituent. And when you have just one line as a substituent, of course, you agree with me that it is what? Methyl. It is what? Methyl. So where are we going to number from? We number from the side that we get to the substituent first. So here become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is what? Decaying. At position number 2, you have what? You have a methyl substituent there. So this gives us 2 methyl, and then here is what? Decane. It's a very simple something, right? 2 methyl decane. All right? So that is that for that particular one. It's a very simple something. All right. Let us see another question under this category of naming. Now, in the exam, like I said, you are not going to see anything like this. This is what they will give to you in the exam. They will say, okay, let's see for this particular one. They will say, okay, so the compound that was given to you is this. This is what will be given to you in the exam. You have something like CH3. They may decide to now abbreviate this as CH2, CH2 into 2 places. Or they will say CH2. Are you getting it? Then bracket 2 to tell you that this CH2, CH2 into 2 places. Then you now have something like CH brackets. Now, whenever you see bracket, know that that thing that follows after the bracket is a substituent. So you have CH3. So what is this one telling you that this one is a substituent? I'm telling you now because this is how the exam will come. The problem with most of you in the exam is you don't know which of them is a substituent and which is not. And when the question comes, it just throws you off balance. And then you have something like CH2 and then CH3. This is how it will come. This compound, you see the same thing as this compound. First of all, we started with CH3, then CH2 into 2 places, which is CH2 into 2 places. Now, someone may now want to ask me, is this one a substituent? No, it's not a substituent. Why? Because CH3 is what is supposed to be here. Then after CH3, you have CH2, CH2. But when you have something like CH, are you getting it? When you have something like CH, it means the valency is not complete. You cannot just have CH3 which continues it like that. This bracket here is telling you that this is what? A substituent. I don't know if you understand what I'm trying to say. I don't know if you understand. This light is entering my eyes badly. Alright? What I'm trying to tell you is that after CH3, most stage, CH3 is what usually starts it. What you are supposed to be having after CH3 is CH2. So if you have CH3, then what follows is CH2. Just know that it's a continuation like CH3, CH2, CH2. The 2 extremes must be CH3 unless there's a double bond. If there's no double bond, the 2 extremes must be what? CH3. So you have CH3, CH3, which is correct. Then after CH3, what should follow should be what? CH2, CH2. But in a situation where you have CH, it means one of the hydrogen has been replaced by a substituent. So whenever you see anything in bracket, that bracket is telling you that that thing now is the substituent that replaced one of the hydrogen. Normally, what you're supposed to have is CH3, CH3, then everything in the middle is supposed to be what? CH2. Do you get it now? So in a situation where you have CH3, CH3, and then every other is CH2, CH2, and then you now have CH, where the other hydrogen go? It has been substituted with a what? A substituent. So whenever you see that substituent now put in bracket like CH3, you know that there's a substituent there. Do you get it? And then we have CH2 and then the other extreme, CH3. Is that understood? What are you trying to understand? Say this thing is supposed to be CH3, CH2, 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 CH3. These are all compounds are supposed to be. They are supposed to start with CH3, ends with what? CH3 for the alkanes. Are you getting it? Now, in the middle, what you are supposed to be having is CH2, CH2. But in a situation where in the middle, you now see, instead of, let's say this one, you now see something like CH3, CH2, CH2, CH. Now, this CH tells you that one of the hydrogen has been replaced. Then after that, you are now going to see something like CH3 and then 2. CH3. What is that one telling you? It tells you that that hydrogen that was replaced with this CH3 here. So this CH3 will now become a substituent on top of this carbon here. Do you understand now? So we have CH3, CH2, CH2, CH, and then the substituent on top, and then you have the CH2 and then CH3. So in the exam condition, how about if you are given something like this? Let's say CH3, CH2, C bracket CH3 bracket 2, and then we have CH3. How do you go about something like this? First of all, we have to bring it up. By normal thing, you are supposed to have what? CH3, then CH2, then here is supposed to be CH2. But the two hydrogens were replaced. And you now see that what were they replaced with? They were replaced with what? CH3, my dear student. So on top here, we have CH3, and under here, you have another word, CH3. That is to tell you that this CH3 and this CH3, they are what? Substituents. And of course, we have CH3 here. Are you getting it? So we are now going to count the longest continuous chain. Which of the chain is the longest continuous chain? If you actually look at this very well, you agree with me that the straight chain in this compound is the longest continuous chain. So if it is the longest continuous chain, how do we number? We number from the side that we get to the substituent easily. Which side we get to the substituent? These are the substituents, methyl, methyl. So here will be number 1, here will be number 2, here will be number 3, here will be number 4. Is that okay? So here becomes 2, 2 dimethyl, and then you have 4 carbons, which makes it to be what? Butane. So the name of this compound is 2, 2 dimethyl butane. Is that understood? It's a very simple something to look at. Do you get the idea now? Do you get the idea? So that is how to go about a question like this. Is that okay? So now, how about if you have multiple substituents? For instance, if you have something like this, let me just give you one Ogbeni-Yanga structure. Now, look at this structure very well. And I say name this structure. First of all, you have to identify the longest continuous chain. Now, how do you identify the longest continuous chain? Look at the S streams. If you take this one, for instance, this one run like this. Sorry about that. This one runs like this. God, I beg you. Now this one runs like this. Here, 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 here. This is the longest continuous chain. Now, if you count this one, if you take it from here, this one runs like this, and then like this, like this, like this, like this, like this, like this. It's not as long as this one. If you count this 1, 2, 3, 4, 5, 6, 7, 8. But if you take this one runs like this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you getting it? So the 9th one is the longest continuous chain. So where are we going to number from? We number from the sides that we get to the substituent easily. So if we number from this side, here will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Every other thing here is a substituent. So this group here is a substituent, this is a substituent, this is a substituent. And each of them, whenever you see just one stroke like this, know that we are talking about methyl. So this is methyl substituent, this is what? Methyl substituent, and this is what? Methyl substituent. Is that okay? So we have 3 methyl substituents. Now, if we now add all the numbers of the substituent together, this is 3, 4, 6. 3, 4, 6 will give us 3 plus 4 plus 6 will give us 13. Now, let us number from this side. Here is 1, 2, 3, 4. This 1, 2, 3. Okay, let me use a different pen. This is actually 9 here. Here is 2. Here is 7. Okay, let me use a different pen to number. This is 1. If we number from this side, 2. Here is 3. Here is 4. Here is 5. Here is 6. Here is 7. Here is 8. Here is 9. If you add these substituents position together, this position number 4, so we'll have 4 plus, the other one is what? 6, the other one is what? 7. That is the other substituent position number 7. If you add 4 plus 6 is 10, plus 7 is how many? 17. So which one has the shortest, as in the smallest number when added together, when summed together? The correct answer is this number, which is with red. So what do you think will be the name of this compound? It's a very simple compound. We already know where the substituents are. There are 3 substituents at position number 3, 4, and 6. And they are all methyl substituents. Now, because they are all methyl substituents, you use tri. So here it gives us 3, 4, right? 6. And then you have tri methyl. 9 carbon is how many? Nonane. All right, that will be the name of that compound. Is that okay? The very simple something, right? All right, let us see another one briefly. Now, how about if you have a compound like this? And you are asked to name a compound like this. First of all, we have to identify the longest continuous chain. Of course, just looking at it, you agree with me that the longest continuous chain is this straight chain here. This is the longest continuous chain. All right? That straight chain is the longest continuous chain. So every other thing there is a substituent. So let us circle our substituent. This is a substituent. This is a substituent. This is a substituent. So we have to number from the sides that we get to the substituent easily. So which side do you think we get to the substituent easily? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? These are numbering. Now, my dear students, having numbered it this way, how about if you go this way? This 1, 2, 3, 4, 5. Then here is what? 6, here is 7. Of course, this one is shorter. Now, what are the substituents we have? The substituents we have, the first one here is methyl. The second one here is what? Ethyl. And the other one here is what? Propyl. Look at it, it's ethyl because this is a carbon here, 2 carbons, ethyl. This one just have 1 carbon, methyl. Then this one here, it has 1, 2, 3, propyl. So we call it propyl. All right? Exactly. So if you want to number or if you want to name this compound, you name them in alphabetical order. E comes before M, which comes before P. Then the parent name will be what? Decane, because it has 10 carbons. So if we want to name this compound, it becomes at position number, we name ethyl first, position number 5. So we have 5 ethyl, right? Then we have 4 methyl. Then we have 6 propyl. You don't give any space again. And then 10 carbons is what? Decane. So this will be the name of this compound. Is that okay? 5 ethyl, 4 methyl, 6 propyl, decane. Is that understood? Exactly. Now, there's a last one I want us to look into when you have a substituent inside another substituent. All right. Now, let us look at something like this. You have a substituent inside another substituent. How do you name a compound like this? Now, first of all, we have to number. If we number, this will be what? Where are we going to take our numbering from? If we take it from this side, 1, 2, 3, 4. Take it from this side, 1, 2, 3. This one gets to the substituent first. So we have 1, 2, 3, 4, 5, 6, 7. If we also take it from here, this one still gives us 1, 2, 3. It's not making it much more. There's something I actually want to show to us, but we can also take it the other way around. And okay, what I will just do is I will just add, let me just add one, because there's actually something I want to illustrate. Let me just add one more. This 1, 2, 3, 4. This 1, 2, 3. Okay. How do we name a compound like this? This 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you getting it? If you come from this side, 1, 2, 3, 4, 5. This one is better, this numbering. Now, but you now discover that for this particular one, inside this branch, this like a substituent. If you now take that numbering system, this is like a substituent. This is another substituent. What substituent is this? Methyl substituent. What about this one? Now, this substituent, as you can see, it has a carbon here. It has another carbon here. It has another carbon here. You can call it isopropyl. Are you getting it? However, you don't just call it isopropyl like that. You can also say, now, since this substituent now has another substituent instead of it, you will now use your normal way of naming organic compound. Is that okay? So the normal way of naming organic compound suggests that you look for the longest continuous chain. Now, the chain is starting from this side like this, somewhere around here. So here will be carbon number 1, and here will be like carbon number 2. Are you getting it? This one is a branching. It's more like the thing they come from this side, but you don't count this carbon as part of it. So coming from this side, here is with number 1, here is number 2. Are you getting it? You don't start your count, because some of you will be like, why don't we just start counting it from 1, 2, 3? No, you count it from what actually attached it to the main compound. So here will be number 1, here is number 2. See that you count 1, and then this side will be 2, or 1, this side will be 2. So it means at position number 1 of this substituent, you have a methyl substituent attached to it. Is that okay? So this is methyl ethene. Is that okay? This is what? Methyl ethene. So how do you name a compound like this? How do you name a compound like this? It's a very simple something. Try use your head and name something like that before we move ahead to naming it by ourselves. Try. Now I told you that you can also call it isopropyl. Are you getting it? Why? Because I told you that when this compound like this, just isopropyl, when the substituent is attached at position number 1, you call it, position number 2, yes. But in this case, how do I want to explain this thing that will make it easier for you guys to understand? Just know that in this case, the way it is, this one is like number 1, here is number 2. Are you getting it? But when you are numbering the substituent, it says here is number 1. If I want to name this compound, I will first of all say methyl ethyl 1-methyl ethyl. Are you getting it? But at position number 4, that is where it is. So we say 4 bracket 1-methyl ethyl. Are you getting it? Why? Because at position number 1, you have what? The methyl group attached to what? Ethyl group. This one here is an ethyl because it has 2 carbon. But at position number 1, you have methyl group. So we say 1-methyl ethyl. But it is attached to the bigger compound at position number 4. So it becomes 4 bracket 1-methyl ethyl. Are you getting it? Then, of course, you have this one here, 5-methyl. Most times you can just name this one first. So here it becomes 5-methyl. Then 4 bracket 1-methyl ethyl, and then how many? Nonane. That's how to name this compound. Or this whole thing, you can also call it isopropyl. Is that okay? Now, if you call it isopropyl, I come before M, but you don't use this thing here. You use the P configuration. So here become 5, or you can say 5-methyl 4 isopropyl, and then nonane instead of the 4 bracket 1-methyl ethyl nonane. Is that okay? That is the general way of naming a compound of this nature. It's a very simple something, but at the same time, it's complicated. All right? Very, very complicated. All right, let me give you another one. Maybe this one may seem confusing. Let me give you another one. Let's try it out based upon this law I just gave to you now. So here you have how many carbon? 9, 2. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly. Then here 1, 2, 3, 4, 5. Here's 1. Are you getting it? And then after this one, you now have CH, C, C. Let's keep it that, okay? CH2. And then here is C. Yes, CH3. Yes, CH3. Yes, CH3. How do you name a compound of this nature? It's very, very easy. Sorry about that. First of all, you know the substituent. Let's number this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whichever direction you number from, to still give you 5, 4, 5, 6, 7, 8, 9. Now, my dear student, which of them is the substituent? This group here is a substituent. Now, in the substituent is attached to the bigger compound at position number 5. So you write 5 out first. Are you getting in bracket? Now, this is your substituent. This substituent here, yes, position number 1. Sorry. For the substituent, yes, position number 1. Yes, position number 2. Yes, position number 3. For the substituent, you are now going to, because the substituent has another substituent instead of it. So here it becomes 1, 2, 3. and there are substituents at position number 2 of the substituent. Are you getting it now? So name the substituent first. Now this is 2, 2. So you say 2, 2. Methyl group, there are 2 of them. So you say dimethyl. Now the full substituent is 1, 2, 3. It has 3 carbon. Propyl, close, bracket close. So you've named the substituent now, but it is attached to the main compound position number 5. That's why we have the 5 outside here. And then the full compound is what? 9 carbons, of which you can name it as what? Non-name. Is that understood? So that's basically how to name a compound like this. Is that okay? I think your alphabetical order will come into play in that regard. Like that iso, the iso supposed, that question we looked at, the I supposed to come, iso supposed to come before the methyl group, right? The I supposed to come before the methyl group. So that is that. All right. So that is that. For ISO, you consider the alphabetical order.